All right, so this is lesson 4, tables of relative frequencies, and a cool down called school attendance. Tables can provide a useful structure for organizing data, especially when that data has multiple categories. So in this case, we call this a two-way frequency table because we're looking at pants versus shorts, and also a second criteria, what season it is. So for this one, 243 participants in a survey responded to questions about their favorite season and whether they like wearing pants or shorts better. The results are summarized in the table. So what this table is saying is that out of 243 people who responded to the survey, there were 21 who said they prefer pants and winter. There's 20 that preferred shorts and spring. So again, two-way tables. We have two criteria that we're looking at, and we organize our data according to both categories at the same time. Now, if we wanted to, we could take that table and turn it into a relative frequency table. And what you do is you take each of these numbers and divide by the total number of people who responded to the survey. And what that's going to do is it's going to give you the probability that if you were to randomly pick a person who was surveyed, the probability that they prefer shorts and spring is 0.08, or you would get that result 8% of the time. Probability that randomly selected from the person likes spring best, what you would have to do is you'd have to look and say, okay, well, wait a minute. I've got 63 total that's prefer spring best, divided by the total number of people, which is 243. So really what we're doing is we are taking the number of what you could call desired outcomes, or the outcome in particular you're looking at, divided by the total possible outcomes in the sample space. So let's look at the cool down. A district is interested in attendance for students in middle and high school. The results for one day are summarized in the table. And if you take a look at those numbers, there's a few questions here. If a student's name is selected at random, what is the probability that they are a middle school student who was present? Well, you have to go to the table where it shows middle school students who were present. And as we can see, there's 8,632 of them. That is the specific group that we're looking at. And you want to take that and divide it by the total possible number of students. Now, the next two questions are a little bit different, and the lesson summary doesn't really cover exactly how to do this. But if a high school student's name is selected at random, notice the difference here. It's not just any student. If we are just looking at high school students and select a name at random, what's the probability they were absent on that day? Well, we have to look at the number of high school students who were absent, but since we're only selecting from high school students, we're not going to look at the total number of students. Our total actually has to be the total number of high school students. Just like question 3 here, if a student who was present that day is selected at random, we're only looking at students present that day. We're not looking at any absent students. What is the probability that a student who's present on a particular day is in middle school? Well, how many students who are present are in middle school? How many students were present total? You take the desired, or the selection that you're going with, and the total for the particular sample space that you're looking for. So be really careful about coming up with your totals. Let me know if you have any questions.